Welcome back to board preparation series for class 10 on my channel Mathify with Minakshi. Today in this video we'll discuss topic wise important questions from chapter 14 probability, which is one of the easiest and scoring chapter in maths. But before we jump into the questions, it is very important to understand what is probability and what are the key concepts and important formulas related to it. So first, we'll quickly revise the definition of probability. Probability is the numerical measure of the chance of an occurrence of an event. I will give you one example here. Suppose you have to find the probability of getting an even number when you throw a die. So here getting an even number, that whatever we want is known as event. Now, what are the total outcomes? Here, as you know that the possible outcomes are 1, 2, 3, 4, 5 and 6. So total outcomes are 6. And what about favorable outcomes? Because we want even numbers, so favorable are 2, 4 and 6. But we have to write number of favorable outcomes. That means 3. So answer is 1 by 2. You should know this fact that favorable outcomes can be less than or equal to total number of outcomes. That's why here we have one result, that probability of an event always lies from 0 to 1. When it is equal to 0, we can say that event is impossible because we are getting no favorable outcome for that. And when it is 1, that means favorable outcomes is equal to total number of outcomes. So we can say it's a sure event. 100% it will happen. Now, we have one more result that you should know, that probability of an event and its complementary, you can say opposite. This bar means its opposite, not E, is always 1. So if you know, example, probability of rotten apples, that it is 0.8. And someone asks, can you tell me the probability of fresh apples? You have to simply subtract from 1 because you know total should be 1. So you will write 1 minus 0.8, that is 0.2. So you should know these two results and the formula for probability. Now it's time to see how these concepts are actually used in exam questions. So I have included important questions from these topics. So let's see all the topics one by one. First, basics of probability. Here the first question is, which one is not a probability of an event? So you should know two, three things here. First of all, probability of an event should always from 0 to 1. Now, if it's a fraction, then you have to see that either it should be proper fraction or it can be whole number like 0 and 1. When it's decimal, then for decimal you have to simply check that it should lies between 0 to 1. And third, when it's percentage, then here you can say from 0% to 100%. So you should know these things, then you can check. 3 by 8, it's a fraction, so it's a proper fraction. That means it is correct. 56% percentage is allowed till 100, so that is also correct. 200 by 3 percentage, again it's a percentage, and when you will solve this you will get somewhere around 66.67. So again that is also correct. Here it's 5.6. In decimal we can only take till 1, so this is the answer. It's not a probability of an event. Now let's move to second question. The probability of selecting a rotten apple randomly from a heap of 900 apples is 0.18. Then the number of fresh apples. You have to find the number of fresh apples. Let's first find the probability of fresh apples. Now we know what is the probability of fresh apples. It is 1 minus probability of rotten apples. That is 0.82. And once you know the probability of something, how you can get the number of that? Simply multiply that probability with total. And total here it's 900. So you will get 0.82 into 900. That means 82 into 9. Yes, and what is 82 into 9? You can check the last digit also, 9 into 2, 18. So we have only one option here, that is 738. Now let's move to next question. In this question it's given probability of guessing the correct answer is A by B and probability of not guessing the correct answer is 2 by 3, and we have to find the relation between A and B. So using this information I can find the probability of guessing because not guessing is given to us. So we'll simply subtract this from 1. That means probability of guessing is 1 by 3. But here it's also given that is equal to A by B. So 1 by 3 is equal to A by B. Now just do the cross multiplication. From here you can say that B is equal to 3A. That means B option is correct. Let's move to next question. From the letters of the word, here from the letters of the word, that means this only you have to see. Mobile. If the letter is selected, what is the probability that it is a vowel? Now, as you are selecting from this word only, you're not selecting from all the English alphabets. So total you will see from here only 1, 2, 3, 4, 5, 6. And we have to select vowels. So vowel are 1, 2, and 3. O-I-N-E, that means 3. So answer is half. So you have to see this word carefully that from where we are selecting. We are selecting from the word mobile. If it's not written, then we'll see all the English alphabets, that is 26. Let's move to next question. A bag contains 5 apples, 6 oranges, and k bananas. If the probability of selecting an apple is given to you 1 by 3, you have to find k. That means number of bananas. Now here it's given that probability of apple is 1 by 3. And what is probability of an apple according to you? It should be number of apples divided by total number of fruits. It is 5 plus 6 plus k. If you will solve what you will get, 1 by 3 is equal to 5 by 11 plus k. Just do cross multiplication. You can say 11 plus k is equal to 15. That means what is your k? If you will transpose 11 to that side, your k is 15 minus 11. That is 4. So your answer is 4. Let's move to sixth question. A number x is chosen from the numbers minus 4, minus 3, minus 2, minus 1, 0, 1, 2, 3, 4, such that the probability of mod of x should be less than 3. What is the meaning of mod of x? That you have to take the absolute value of x. That means just the numerical value, not the sign. So that means minus 2, minus 1, 0, 1, 2. How many? 5 out of 9. So answer is 5 by 9. Let's move to next question. A man is known to speak truth 3 out of 4 times. So probability that he will speak truth is 3 by 4. And the probability that he will lie is 1 minus 3 by 4. That means 1 by 4. Now let's see the question further. He throws a dice and a number other than 6 comes up. Is it possible? No, it's not possible. So it's an impossible event. It's not possible. Now what they said, find the probability that he reports it's a 6. That means what is the probability that he will lie? Because that can't happen. So probability of lie is 1 by 4. That's your answer. Let's move to eighth question. Probability of E plus probability of not E is X. And we know using this formula that this is 1. So here X is 1. You have to simply put the value of X here. So that means 2 into 1 square minus 4 into 1 plus 7. If you will solve what you will get 2 minus 4 plus 7. That means minus 2 plus 7 and the correct answer is 5. Let's move to next question. A letter of English alphabet is chosen at random. Now here they said English alphabet. So total you will take 26. What is the probability that it is a letter of the word mathematics? So we'll count one letter only one time. So 1, 2, 3, 4, 5. M is already counted. A also, T also. We'll write 6, 7, and 8. So answer is 8 by 26. You can solve it further. That is 4 by 30. Okay, so we can select 8 alphabets out of 26 to get the word mathematics. Now it is not a vowel. Again, this question is not related to first part. You have to just see that from English alphabets, how many are not vowel? That means consonants. It's 21 is the answer. Let's move to next topic, dice. First question, assertion reason. Assertion, the probability of getting a doublet in a single throw of pair of dice is 1 by 6. I have already attached picture for you. You can see what is doublet. Doublet means when the numbers are same, like 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6. So we have 6 doublet out of 36. If you will solve, you will get 1 by 6. That means your assertion is true. Now let's move to reason. It's saying for any event, probability always lies from 0 to 1. That is also true. But is it a correct explanation? Did you use this reason while solving assertion? No. That means answer is B. It's not the correct explanation. Although both are true, but not the correct explanation. Let's move to second question. Second question. A fair dice is rolled, then the probability of getting a number x such that x is from 1 to 6. Now we know that when we throw a dice, we will get 1, 2, 3, 4, 5, 6. That means total outcomes are 6. And here the favorable is from 1 to 6. That means favorable also 6. So that's a sure event. Answer is 1. Let's move to third question. When we throw two dice, find the probability of getting doublet. You know, doublet means that on both the dice we have same number 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6. As you can see in this image, so we have 6 by 36. That is 1 by 6. Let's move to second part. Difference of numbers on their upper faces is equal to 2. When we say difference, that doesn't mean that first minus second or second minus first. You can take in any order. So let's take 1 3 3 1. Here the difference is 2. Then 2 4 4 2. Then 3 5 5 3. 4 6 6 4. Now we can't take after that because 5 7 and 7 we don't have. So how many possibilities are there? Favorable are 8 and total are 36. If you'll cut with the table of 4, you will get 2 by 9. Let's move to third part. First number greater than second number. If you will see this image carefully, so just see below the diagonal. First number is always greater than second number. And above the diagonal, first number is less than second number. Answer is always 15 out of 36. And when you will solve, you will cut with the table of 3, you will get 5 by 12. Let's move to fourth part. Sum of upper faces is odd. If you will see carefully, here what's the sum? 1 plus 1, it's 2. Then 1 plus 2, 3. Then 1 plus 3, 4. Then 5. Did you realize something here? Yes, every alternate sum is odd. That means we have 18 out of 36. Similarly for even, 18 out of 36. So answer is half. You have to always write your answer in simplest form. Now let's move to fifth part of this question. Sum of upper faces is a multiple of 4. Now this means that your sum can be 4, then 8, then 12. Last is 6 by 6, so maximum possible sum can be 12. So let's write the outcomes now. For 4, we can have 1 3, 3 1 and 2 2. For 8, we can have 2 6, 6 2, 3 5, 5 3, 4 4. For 12, only 1, 6 by 6. So favorable outcomes are 1, 2, 3, 4, 5, 6, 7, 8, 9. That means 9 by 36. And if you cut with the table of 9, what you will get? 1 by 4. Let's move to sixth part. Sixth will not come on either of them. So if you will see carefully this line, I will show you this one and this one. Only in these we have 6, but the remaining one, these 25, we don't have 6. So we can say 25 by 36. And this holds for all the numbers. If they will write 4 will not come up on either of them, 5 will not come up in either of them, answer will be same 25 by 36. Now, seventh part, 6 will come up on at least 1. For at least one, that means either one time or on both 6 can come. So that means you have to add these all 1 2 3 4 5 6 7 8 9 10 11. So answer is 11 by 36. Now 6 will come upon both of them, then it's only 1. Let's move to next. 6 will come up exactly 1. Now this time we need exactly 1. So exactly 1 you will not include the 6. That means 10 by 36. Now product of upper faces is a perfect square. Now for which numbers you will take the product, like 1 into 1 is 1, 1 into 2 is 2, 1 into 3 is 3. So when you will take the product, how many times will get perfect square? First thing is simple, the doublet will always give a perfect square. You can see 1 into 1 is 1, then 4, 9, 16, 25 and 36. So we know 6, so we have. Will any other outcome will give you perfect square? Think. Yes, you know that you will also get perfect square in 1 into 4 and 4 into 1. So we have 8 in total. 8 by 36. When you will cut with a table of 4, you will get 2 by 9. Now let's move to next topic. Coins. If three different coins are tossed together, find the probability of getting. So first I will write the total outcomes like this, and other will fill with a different one. Like here H, then will fill with T. This is T, so I will fill H. So total we have 8 outcomes. So in denominator 8 will come for all the parts. Now we have to think for numerator. Two heads. So you can count two heads. In three cases we have two heads. So answer is 3 by 8. But I will also want to tell you one trick for this. When we have three coins, we have to just take the 11 cube. That is 1, 3, 3, 1. Now for head you will write the counting like 0, 1, 2, 3. And for tails you will write reverse 3, 2, 1, 0. Now just see the number for 2 corresponding to 2, that is 3. So your answer is 3 by 8. When it's at least two tails, that means either two or more than that, three. So we always see opposite. Least, when the word is least, we'll see two or more than two. So just circle tails, two tails. Now we have to select two or more than two, that is three. So just add 1 and 3. Answer is 4 by 8. You can write half. Now at most one head, just see the word head, one, it's here. But again you have to do opposite. It's most, you will see less. That means again you will add 1 and 3, 4. That is again half. At most two tails. I will rub this first so that it will be easy for you to understand this trick. Now two, at most two tails. Again you will circle tails, that is two tails. At most you will have to do opposite. That means you will take the lesser number 1 and 0. So just add these 3, 3, 3, 1, that is 7 by 8. I hope that you like this trick. Otherwise you have to add with the help of all the outcomes. Now let's move to next topic. Balls. A bag contains 5 red balls, n green balls. If the probability of drawing a green ball is 3 times the probability of red ball, that means what is the probability of drawing red ball? Let's write that first. It's 5 by total balls, and total are n plus 5. And what is the probability of getting green ball? That is again number of green balls, that is n divided by total n plus 5. Now according to the question, what is given, that probability of green ball, that means n by n plus 5, is equal to 3 times of red ball, that is 5 by n plus 5. So you can cut n plus 5 and n plus 5. Now you will simply get n as 3 into 5, that is 15. B option is correct. A bag contains 12 balls, out of which X balls are black. That means total are 12 and black balls are X. What is the probability that if you will draw a ball, you will get black ball? So it's very simple. You can say number of black balls, that is X by total. Now, if 6 more black balls are added, so now total is 12 plus 6, that is 18. And now black balls are x plus 6. So new probability, you can say new probability, that is x plus 6 by 18. Now there is one relation between these two probabilities. Let's see that. Probability of drawing a black ball becomes double of what it was before. That means this probability is double of what it was before. This one. Now, what we can cut? You can cut with a table of 6. That is, it's 2 and it's 3. Then you can cut 2 and 2. So you are left with x plus 6 by 3 is equal to x. If you transpose this, you'll get x plus 6 is equal to 3x. And if you transpose x to that side, you will get 2x is equal to 6. This implies your x is 3. This is your final answer. Now let's move to next topic. Slips or card bearing numbers. A box contains cards bearing numbers between 7 to 72. So I want to tell you one trick here. Whenever you have to count numbers between something to something, total numbers, how you can count that? Just take simply the difference of numbers and subtract 1 from that. And whenever the word is from something to something, then you will simply take difference plus 1 to get the total outcome. That's a direct formula that you can learn. So here difference 72 minus 7 minus 1. That means 65 minus 1. So total outcomes here you will write 64. Now, first question is one digit number. From these numbers, let me write that 8, 9, 10 and so on till you have 71. Now, one digit number we have only two, that is 8 and 9. So answer is 2 by 64. You can write 1 by 32. Second, number divisible by 5. Now you know that from 1 to 70, because here we have 71, from 1 to 70, how many numbers we have that is divisible by 5? Just divide 70 by 5, you will get 14. But we don't have 5, that means total we have 13. You can simply do like this, 13 by 64. Now let's move to third part, an odd number less than 30. Now less than 30, how many odd numbers we have? We have 15 odd numbers. But here, what we don't have 1, 3, 5, 7. That means we have to subtract 4. That means we can write 11 by 64. Total, you will take 64 only. You will not take 30. Okay. Now let's move to fourth part. A composite number between 50 and 70. Now you should know prime numbers between 50 and 70. Prime numbers between 50 and 70 are 53, 59, 61 and 67. So we have four prime numbers between this. And how many numbers we have between 50 and 70? As I just told you, difference minus 1, that is 20, minus 1, that is 19. Out of 19, 4 are prime. That means remaining 15 are your composite numbers. Now, can we cut this further? No. So that's your final answer. Let's move to fifth part. Neither divisible by 3 nor by 5. This one you have to see carefully. Whenever the words is neither nor, what you will do, I will use different color for this. It's important. You will write 1 minus probability of either divisible by 3 or 5. Now, how we can find the probability of either or? You will simply take probability of divisible by 3 plus probability of divisible by 5, and then you will subtract probability of divisible by both 3 and 5. So let's solve this. 1 minus. Now, how many numbers are divisible by 3? If you will count this, you will get 21. 21 by 64. For divisible by 5, it's 13. And for divisible by both 3 and 5, that means LCM by 15. LCM of 3 and 5 you have to check in this case. Divisible by 15 are 15, 30, 45, 60. 4 numbers. So you will subtract those 4. What you will get? You will get 1 minus 30 by 64. And that is 64 minus 30 by 64. You can say 34 by 64. So your answer is 17 by 32. This is your final answer. Now let's move to next question. There are 100 cards in a bag numbered from 1 to 100. This one is easy because we have to include 100. That means total are 100. So we'll write 100 for all in denominator. Now, first is divisible by both 9 and 5. Whenever the word is both, that means simply their LCM. You have to simply check number are divisible by 45. So we have only two, that is 45 and 90. You can write 2 by 100, that is 1 by 50. Second, number with repeated digits. Now repeated digits means 11, 22, 33, 44, 55, 66, 77, 88, 99, and 100, because here also 0 is repeating. So you will write 10 by 100, that is 1 by 10. Now third part, divisible by 7 or 5. That means you have to take probability of numbers that is divisible by 7 plus probability that is divisible by 5 minus divisible by both. That means divisible by the LCM, you can say 35. So let's find that. Probability of divisible by 7. As we know, total numbers are 100. So just read the table of 7 where you can take till the number less than 100 or 100. So we know 7 into 14 is 98. So we can take 40 numbers. Now again read the table of 5. We can take 5 into 20 is 100. That means we can take 20 numbers that are divisible by 5. For 35, it's 35 and 70, only two numbers, so we have to subtract that. So answer is 34 minus 2, that is 32 by 100. If you will solve this, what you will get? You can solve with the table of 4. So you'll get 8 by 25 is the answer. Let's move to next part, a composite number. Now you should know that from 1 to 100 we have 25 prime numbers, and 1 is neither a prime nor a composite, so we have to leave 1 and 25 numbers. That means we have to subtract 26 numbers from 100 because those all are composite. So remaining ones are 74 by 100, and your answer is 37 by 50. Let's move to third question. One ticket is selected at random from 100 tickets numbered 00, 01, 02 till 99. If x is the sum of digits and y is the product of digits, find the probability that x is 9 and y is 0. Just focus here that product is 0. When product is 0, when one of the digit is 0, yes, that means we can take 0, 0, 0, 1, 0, 2, 0, 9 and 10, 20, 30. But here there is one more condition that sum should be 9. So when it is possible, only in two cases, 0, 9 and 9, 0. Here the sum is 9 and product is 0. That means 2 out of 100. You can say 1 by 50. Now let's move to next question. At a fate, card bearing numbers from 1 to 1000 are placed in a box. Each player selects one card at random and the card is not replaced. Just see this word carefully because in this question we will not replace the card. If first person select one card, then for the next person we have only 999 cards. If the selected card has a perfect square greater than 500, that means if your number is a square that's greater than 500, then the player will win a prize. So probability that the first player wins a prize. Now we have to think for the number that's a perfect square and it's more than 500. So you know that first perfect square that's more than 500 is 529. It's 23 square. Then 24 square, 25 square. No need to write, just see. Till when the number is less than 1000. 26 square, 27 square. If you know that 32 square is 1024, then what is 31 square? 28 square, 29 square, 30 square is again 900. That is also less than 1000. Now 31 square, if you know the trick to find 31 square, that's 1 square is 1, that's 0, 1. 3 square is 9, 0, 9. And then 3 into 1 is 3, 3 into 2 is 6. So you can write 0, 6. So that means it's 961. At last you will add. So last number can be 961 because after that we have 32 square, that's 1024. So we can't take that because we have numbers till 1000 only. So we have to see how many numbers we have from 529 to 961. We have 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. We have 9 numbers. So probability that first player will win a prize, that's 9 by 1000 because only 9 cards will fulfill this condition. So answer is 9 by 1000. But for the second player, the possibilities are only 8 out of 999. Now let's move to next topic, deck of cards. As you can see, I have also attached the image for reference. First, one card is drawn from a well shuffled deck of cards. Find the probability of drawing 5 of club. Now you know where is club here, We have 1 5 in club and total are 52. So answer is 1 by 52. Second, a red king. How many king we have of red color? One from heart and one from diamond. That means 2 by 52. You have to always write in simplest form. So I will write 1 by 26. Second, spade or face card. So whenever we have or, that means you have to add the probability of spade with probability of face card, and then you have to subtract the probability of both. That means spade and face card. So let's solve this. Now, probability of spade cards. How many spade we have? 13. Plus face card. How many face card we have? 12. And minus face card as well as spade. Now just see here, spade. In spade, how many face cards we have? 3. So you can write minus 3 by 52. Let's solve this. 13 plus 12, 25 minus 3. You can say 22 by 52. If you will solve, you'll get 11 by 26. So this is your final answer. Let's move to next. Black and ace. And means we again need both, or you can just remove this word. In and, if you will remove this word, just read it together. Black ace. How many black ace we have? In black, we have 2 ace, one in spade, one in club. That means 2 by 52. 1 by 26 is the answer. Neither black nor queen. I told you what you have to do. Subtract either black or queen from 1. Now we'll find the probability of black plus probability of queen, and we'll subtract probability of black queen. Black and queen means black queen. So let's solve this. 1 minus probability of black. How many black cards we have? We have 26. How many queen we have? In queen we have 4 queens. One from heart, one from diamond, one from spade, one from club. And black queen are 2. One from spade, one from club. So total is 1 minus 26 plus 4 is 30. 30 minus 2, that's 28 by 52. So that means 52 minus 28 by 52. You can say 24 by 52, and in simplest form you can say 6 by 13 if you look at the table of 4. This is final answer. Okay, so I'm writing here too. Let's move to next question of deck of cards. Question number 2. Red queens and black jacks are removed. This is important that here these cards are removed from a pack of cards. So let's cut that. Red queens. In red we have where we have queen here. Cut that. We don't have now. And black jack cards. In black jack. So we have removed 4 cards. That means now from total we have just 48. Okay, in total we have 48. Now, so I'm writing 48. Total we have 48. So that you will not skip this part, that now will not write 52. Okay, first red color. How many cards we have of red color? Earlier we have 26, but now we have removed 2. So now we have 24 of red. If you will solve this, you'll get half. Similarly, here also now you are left with 24. Now, a multiple of 3. How many cards we have a multiple of 3? Just see. 3, 6, 9. Here also 3, 6, 9. And here 3, 6, 9. Basically, in all 4, we have 3, 3. So that means total you have 12. You can write 12 by 48. That's 1 by 4. You have to always convert in simplest form. Otherwise, your half marks will be deducted. A queen of black. So in black, you have to see queen. So we have 1 and 2. So answer is 2 by 48. You can write 1 by 24. Now a jack. How many jack we have? 1, 2. Because 2 we have already removed. So we have just 2 now. So answer is 1 by 24. Or red or king. That means I will solve this part here. Fifth. Red or king means you will see probability of red plus probability of king And then you will subtract both, that is red king. So let's see. Probability of red. How many red cards we have now? We have just 24. How many king we have? We have all 4 king with us. And red king we have to remove. How many red king we have? 2. So your answer is 28 minus 2. That is 26 by 48. You can write 13 by 24. So this is your final answer, 13 by 24. Let's move to sixth part. In sixth part, it's neither nor. That means you have to subtract either or from 1. Probability of either ace or face card. So it's very important, neither nor, either or, and. So 1 minus probability of ace plus, let's write in bracket, plus probability of face card minus probability of ace and face card. We need both. A card that is ace as well as face card. Now, 1 minus probability of ace. How many ace we have? As you know, we have 4. 4 by 48. How many face card we have? As you can see here, we have already cut 4 face cards and total we have 12. That means we are left with 8 now. 8 by 48. And minus ace and face card. Now we know it's not possible that the card is ace as well as face card because ace doesn't come under face card, so you will write 0. So you can write 1 minus 12 by 40. Yes. And what is 12 by 48? If you cut with a table of 12, it's 1 by 4. 1 minus 1 by 4, that is 3 by 4 is the answer. Here, its final answer is 3 by 4. Now let's move to next topic, month, days and year. First question, a month is selected at random from a year. Find the probability that it is March or June. That means either March or June. We can select 2 months out of 12. So answer is 1 by 6. Let's move to next question. Tony and Mona go to an ice cream parlor where 5 different varieties of ice cream are available. If they order one ice cream each, find the probability that both order the same variety. Let's write the total outcomes that are possible. Suppose we have 5 flavors, 1, 2, 3, 4, 5. I'm writing number for flavors, 1, 2, 3, 4, 5. So if Tony orders one, we have possibility for Mona, 1, 2, 3, 4, 5. That she can take any one. If Tony selects 2, then again possibilities for Mona, 1, 2, 3, 4, 5. And then again, if Tony selects 3, possibilities for Mona, again 1, 2, 3, 4, 5. Tony selects 4th, again Mona have possibilities 1, 2, 3, 4, 5. Now Tony selects last flavor, again Mona have 5 possibilities. That means total we have 25. Now both have ordered same variety. That means 1, 1, 2, 2, 3, 3, 4, 4, 5, 5. That means 5 by 25. You can say 1 by 5. If they will say both order different variety, then answer is 20 by 25. You can say 4 by 5. Let's move to next question. Savita and Hamida are friends and born in 2001. What is the probability that both will have different birthdays and same birthday? Just see that 2001 is a leap year or non-leap year. You have to just see the last 2 digits. It's 01, not divisible by 4. You can say it's a non-leap year. So number of days, total days are 365. So for different birthdays, you will say answer is 364 by 365. And for same birthday, there can be only one day in a year. So you can say 1 by 365. Easy. And if it's a leap year, then the answer will be 365 by 366 and 1 by 366. What is the probability that the month of January, that means we have 31 days in Jan, will have exactly 5 Mondays, 5 Tuesday and 5 Wednesday? First of all, you should know that in this we have 4 complete weeks because 28 days, and then we are left with 3 days. So we have to make the combination of these 3 days, whatever we are left with. If it's 30 days month, then you are left with 2 days. You will make a combination of 2 days. So let's write that: Sunday, Monday, Tuesday, Monday, Tuesday, Wednesday, Tuesday, Wednesday, Thursday, Wednesday, Thursday, Friday, Thursday, Friday, Saturday, Friday, Saturday, Sunday, and last Saturday, Sunday, Monday. After that, you will get again Sunday, Monday, Tuesday. That means you have to stop. Now, first part, exactly 5 Monday, 5 Tuesday, and 5 Wednesday. That means 3 days that we're left with. We need five. Fifth one Monday, another one is Tuesday, and another one is Wednesday. So that's only one combination, as you can say Monday, Tuesday, Wednesday. So answer is 1/7. Total, we have 7 possibilities. Now, or that means either 5 Monday or 5 Tuesday or 5 Wednesday, any one. If it's true, we will count that. So here we have Monday, here we have Monday, Tuesday. So if any one is coming, you have to take that. Now Tuesday, and also here Wednesday. Here we don't have anyone, so we'll not count this, will not count this. Here we have Monday. That means 5/7. Yes, 5/7 and 1/7. Let's move to next question. Two customers, Sham and Ekta, are visiting a pastry shop in the same week, Tuesday to Saturday. Each is equally likely to visit the shop on any one of the 5 days. Find the probability that both will visit the shop on same day, consecutive days, and different days. Again, the possibilities are Tuesday, like Sham can go on Tuesday. Then for Ekta, we have possibilities Tuesday, Wednesday, Thursday, Friday, and Saturday. Similarly, now Sham will go on Wednesday. Then again, Ekta have choice Tuesday, Wednesday, Thursday, Friday, and Saturday. Similarly, now Thursday will fix Thursday, Tuesday, Thursday, Wednesday, Thursday, Friday, Thursday. This one is Thursday, Thursday, then Thursday, Friday, Thursday, Saturday. Now Friday will be fixed Friday, Tuesday, Friday, Wednesday, Friday, Thursday, Friday, Friday, and Friday, Saturday. And last, Saturday, Tuesday, Saturday, Wednesday, Saturday, Thursday, Saturday, Friday, and Saturday, Saturday. These are the total possibilities. That means 25. In all the cases, 25. Now, on the same day, for same day, what are the possibilities? Just see carefully. For same day, same days are here: Tuesday, Tuesday, Wednesday, Wednesday, Thursday, Thursday, Friday, Friday, and Saturday, Saturday. That means 5 out of 25. You can say 1/5 if we'll solve. And similarly, if you know the same day, then for different day, the remaining ones you can say 20/25. That is 4/5. Now we have to think for consecutive days. Like one is gone on Tuesday, then another one will go on Wednesday. So for that only you will count Tuesday, Wednesday, and Wednesday, Tuesday. Both are consecutive. Then you will say Wednesday, Thursday, Thursday, Wednesday. Now Thursday, Friday, Friday, Thursday, then Friday, Saturday, and Saturday, Friday. So you have 8 days. So here answer is 8/25. Yes, let's move to next question. Find the probability that a leap year selected at random will contain. Now you should know that in leap year, how many days we have? We have 366 days. And in non-leap year, we have 365 days. Now again, it's talking about weeks. So we'll divide that by 7. That how many weeks we have? 7 into 5 is 35. We are left with 1. And then here 16. 7 into 2 is 14. That means it will contain 52 complete weeks and 2 days left. We're left with 2 days. Similarly, when we divide by this by 365 by 7, what we will get? Let's see. 365 by 7. Again, 5 is 35, left is 1. You will carry 5. It's 214. That means now it carry 52 weeks, complete weeks, but 1 day is left. So here, when 2 days left, so you have to write all the possibilities like Sunday, Monday, Monday and Tuesday, Tuesday and Wednesday, Wednesday and Thursday, Thursday and Friday, Friday and Saturday and Sunday. And for 1 day, it is Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday. These are the possibilities. In both the cases, we have 7 possibilities. 7 here and 7 here. We have to see for favorable now. Okay, first case 53 Sundays. That means 2 days left. Out of those 2 days, 1 day is Sunday because 52 so we have complete. 52 weeks we have complete. So 1 day is Sunday. We can select this one and this one. So 2 by 7. And what about here? 1 day is Sunday, only one, this one. So 1 by 7. 52 Sundays. That's a sure event because we have 52 complete weeks. 7 by 7, 1. For next 54 Sundays, maximum any day can come, that's 53. So for 54, it's not possible that both the days are Sunday. So that's impossible event. And 53 Sunday, 53 Monday, that's we have to select one combination where Sunday, Monday will come. That's single one. We need both Sunday as well as Monday. That's 1 by 7. Here, 52 Sundays, again, we have 52 complete weeks. It's a sure event. That's 1. For second 54 Sundays, not possible. Hardly we can say that we have maximum 53 Sundays. So that's impossible event. You will write 0. 53 Sunday, 53 Monday. Here we have only 1 day left. So we can have either 53 Sunday or 53 Monday, not both at a time in case of non-leap year. So again, that is 0. Now let's move to last topic, hearts. A bag contains 5 red balls and 7 black balls. So total balls are 5 plus 7, that is 12. A ball is drawn at random and then replaced, and then another ball is drawn. So this is a different question. Here you are selecting a ball 2 times, but you are replacing also. Both are red. That means first the probability that the ball is red is 5 by 12. Again you have to multiply because you're selecting one more time. So again the probability of bread is 5 by 12 because you have replaced that. So answer is 25 by 144. In case you will not replace, then your answer will be 5 by 12 into 4 by 11. But here you replaced. Both are black. That means again first is black, 7 by 12, again 7 by 12. So here I'm repeating again, you have to put a multiply sign. 7 into 7 is 49 and 144. This time one red and one black. Suppose first time I've selected red ball and then black. Or here we have two options. First you will select black and then you will select red. So in this case, in between you will add plus because we have two possibilities here. What I will get? 35 by 144 plus 35 by 144. That is 70 by 144. And if you will solve, you will get 35 by 72 if I'll cut with the table of 2. So these are your final answers. Let's move to last question. How many 3-digit integers have the 100 digit as 8 and unit digit as 7? You know how 3-digit number looks like this. This is ones, this is tens, this is 100. They are saying 100 digit is fixed 8 and ones digit is 7. Now, what are the possibilities that I can select for tens digit? We can select the 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. We can select any digit here. That means total possibilities are 10 because 8 and 7 are fixed. What about the total number of outcomes? This is for favorable. Now for total, you know how many 3-digit numbers we can frame. For first, you can use any digit except 0. That means from 1 to 9. So we have 9 possibilities. But for second and third digit, you can also select 0. That is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. That means 10 possibilities here, 10 possibilities here. So you can say in total, we have 900 possibilities to select 3-digit number. So answer is 1 by 90. This is your final answer for this question. Now, It's time for your concept checkpoint. Solve this question and drop your answer in the comment box. From the first chapter to the last, we did this together. Now step into your exams with belief because you are truly ready. All the very best, everyone. If you like this video, don't forget to like, share, and subscribe to my channel, Mathify with Minakshi. Thank you, everyone.